in a circle, if a radius is perpendicular to a chord, which means that it creates a right angle. If your radius is perpendicular to your chord, or you could have the whole entire diameter, then that radius or diameter is going to bisect that chord. So it's going to cut that chord in half. This piece is going to be congruent to this piece. When a radius is perpendicular to a chord, the radius bisects that chord. And that radius also bisects the arc. So if you think of that chord, if you connect the endpoints of the chord, it creates an arc. So it's going to bisect the arc. This part of the arc is going to be congruent to this part of the arc. And that works in the opposite direction as well. If we know a radius is bisecting a chord or its arc, then you can go ahead and say that that radius is perpendicular to the chord. Another property is in a circle or in two congruent circles. If you have two chords, they are congruent if and only if they're equidistant from the center. So remember we talked about the shortest distance between a point and a line is the perpendicular distance. So if the perpendicular distance from the center to one chord is the same as the perpendicular distance from the center to the second chord, then if those two distances from the center are the same, then that means that that whole chord is congruent to the second chord. And if these two purple circles are congruent and I have a chord over here and I'm wondering if it's congruent to a chord over here in a completely different circle, if I know that the distance from the chord to the center over here is the same length as the distance from the chord to the center of the circle over here, since I know the circles are congruent, then I could say that those chords are congruent as well. So in this example, we know that from F to A is 6. So this is 6 right here. And then from F to E is 4. So if A is the center of my circle, then AE is a radius. So if I put those two pieces together, then my radius AE is 10. My radius is 10. And so I want to figure out what the length of CD is, this chord. Well, my radius is forming a right angle with that chord. It's perpendicular to the chord. So it's going to bisect that chord. This nugget CF and this nugget FD are going to be congruent. That's the property we just learned. When a radius is perpendicular to a chord, it's going to bisect the chord. So you might be thinking, okay, how am I going to figure out the length of that chord? Well, we want to think about using the radius to our advantage. Remember, any radius anywhere, even, right here, that radius, those radii are all the same length. They're all 10. So I'm going to strategically place a radius here because I know it's 10. Oh my gosh. I just created my favorite shape ever, a right triangle. And when you have a right triangle and you have a missing side, you can do Pythagorean theorem to find the missing side. So I can do x squared plus 6 squared equals 10 squared. And x ends up being 8. And so I know that this radius is bisecting this chord. So if CF is 8, then FD is 8. And so CD, that whole enchilada, is 8 plus 8, 16.